All right, we're going to do the system of equation problems from the review. Remember, all the answers for the first part of the review are on Delta Math. But just want to go over each one of these and make sure we understand everything. Now, keep in mind there are multiple ways of doing these correctly. So if you do it different from me but get the same answers, then that's totally fine, as long as you can prove it with all the work that you show. Okay? So on the first one, since you got a y equals, it's already primed and set up to do a substitution, so that this y is the same as 2x plus 1. All right? So I'm going to start by substituting that in. X squared plus, in parentheses, 2x plus 1. Okay? And we got squared equals 10. So I have an equation with one variable that I can solve. It looks like it'll be quadratic because I got a couple squared terms here. First thing I want to do is expand the 2x plus 1 squared. Okay? So I will get 4x squared plus 4x plus 1 now equal 10. I have some like terms here. So I have a 1x squared and a 4x squared. That makes 5x squared. And the 4x will just stay the same. That doesn't combine with anything, so that just drops down. And to solve a quadratic, I need it to be equal to 0. So this 10 and 1 are both constants, so I'm going to move that 10 over. Subtract 10 on both sides, right? So I'll have a minus 9, and now it's equal to 0. So all quadratics have to be equal to 0 when you solve them. Now you can solve this many ways. Most people would say, let's just do factoring. Now remember that there's a term in front that is 5. So we can't just say, what two numbers multiply to negative 9 and add to 4. We have to consider this 5x. Okay? So in short, when you're doing this, in order to get a 5x squared, you know the factors of 5 are just 1 and 5. So I'm going to have a 5x and a 5, right? The question is, what will the other numbers be? So you can do a couple little techniques. Some people learned like doing the x, right? And when you're doing the x with a number in front, you actually multiply these two together. So what two numbers multiply to negative 45? Right? X squared. And then they add to the bottom number here, which is positive 4x. Right? So from there, you come up with two numbers. What multiplies to negative 45? Probably 9 and 5 come to mind right away. 9x and 5x, right? And to get 4 and to get a negative, we'll have the 5 be negative. Okay? Now that doesn't help you fill this in, right? You still need to find out what these terms are. So most people probably know this through doing the box. So I'm going to take my first and last term right here, right, which is 5x squared, and I got my minus 9 right here. And the two terms I got here, that's what I'm going to put in the empty places. Okay. Now I can do some factoring. Again, we'll get 5x, what multiplies to 5x squared, we'll get 5x, get 5x up here, right, because there's 5 in both of these, and next right here. So it's like I'm doing the GCF. What do these two have in common? Well, they both have a 5 and they both have an x, so I can take that out. And what do these two have in common? They both have an x in common, and of course they should multiply. 5x times x should multiply whatever's in here. And then we just work backwards. So x times what equals 9x? So we'll get plus 9. So now we know that this term is going to be 5x plus 9. And then 9 times what gives me negative 9? That'd be negative 1. And of course that's also the GCF for this row. Negative 5x and negative 9. The common number would be negative 1. So that's our other factor. Okay. Now this is equal to, let me squeeze that in, equal to 0. Okay. So that means either one of these, 5x plus 9, is equal to 0, and x minus 1 equals 0. So that's how we get our two x values. So I'll just solve each of these for x. So I got negative 9/5 for one of them, and this other one's a little more simple. Just add 1 to both sides. So those are my two x values, negative 9/5 and positive 1. Okay, so that's the end of the first part. Now I need to plug each of these back in, right, and see what we get. So we got x equals negative 9/5. Okay, plug that back into either one. Now, it would probably be easier if I use the second one, because it's already solved for y, so I'm going to do that. So we have 2 times negative 9/5 plus 1. There we go. So I just need to simplify this. And you can use calculators. So we don't want to say, well, it's 9/5 or negative 9/5, so therefore this is a harder problem. Use your calculators, right? See what you get. It doesn't take that much effort to just punch it in. So this will come out to, when you punch it in, I think negative 13/5 will be our y. So our first solution is going to be negative 9/5, comma, negative 13/5 as well. Okay, so there's our first solution. Now we got one more. Let's use blue. And x equals 1. A little bit easier to plug in x equals 1. Okay, so same equation. So just 2 times 1 plus 1 equals y. That'd be 2 plus 1, which is 3. So our second solution will be 1, comma 3. So there we go. Two solutions. Right here and right here. That means this straight line and circle intersect at 2 places. Now, if you want to pull up Desmos and graph them, you can physically see where exactly those intersections are. And you will not need to do that on the quiz, though. That's just for your own verification. Okay. All right. Let's go down to 17. All right. So same idea. We have to figure out how to cancel something out. Now there's a couple ways of doing this. Most people will probably multiply the top equation by negative 4, right? So if I do that, like this, you see I'll end up with a negative 4x squared, and that will add up with a positive 4x squared and cancel out. So that's one way of doing it. I'm going to show you probably a different way. It's in your best interest to have smaller numbers. So if you recognize from the beginning that, well, you can divide this equation by 4 instead, that'll make all these numbers a lot smaller. You don't have to do it this way, but it's just another way of thinking about it. Okay? So I'm going to keep the top equation the same. Right? The bottom equation, just divide everything by 4, because all these numbers are divisible by 4. And I'll bring all these values to be much smaller and therefore easier to work with. So it's still negative because I need to have a negative x squared. Right? Divide 36 by negative 4. I'll have 9y squared. And I'm going to move this 144 to the other side. It'll become positive 144. And then divide that by negative 4. And that comes out to negative 36. So already you can see that this is a much easier system to work with much smaller numbers. So nice little trick. So we'll get negative 8y squared equals negative 11. And we divide both sides by the negative 8, so we'll get positive 8 over 11. And then we'll take the square root of both sides, so we'll have plus or minus square root of 8 over 11. I'm sorry, 11 over 8. Yeah. So not the nicest of number, but we can still work with this, and that's one of the reasons for having this on there, is that just because the numbers don't come out to nice whole integers, like here we got fractions, here we got radicals, it doesn't mean the problem can't be solved. It just takes a little more effort to take care of the details, right? So we're okay with this, right? Now we need to take each one of these, the positive root 11 over 8 and the negative root 11 over 8, and plug those back into probably the top equation because it's a little bit easier. So I'm going to plug that into here. So we got x squared plus Now let's do the positive. Notice how we're just going to square it, so immediately we drop the square root. So you can see, even though we have a radical here, it ceases to exist pretty fast. So we just have a basic fraction problem. So we'll subtract 11 over 8 on both sides. Again, use your calculator. Don't need to do this manually. And you'll get 189 over 8. And then once again, take the square root of both sides. So we'll have plus or minus 189 over 8. Now your calculator might rationalize these depending on which calculator you have. It's not really needed here because we're just getting a general answer. Okay, so don't worry too much about the radical work and simplifying these. Just keep it simple. Okay, so there we have our two answers, right? We have our plus or minus for our y, or plus or minus for our x. So we could write it out a simple way, which is, it's okay for this quiz. X is first, and then my y's. The thing that you need to realize that this means there are 4 solutions. That's what's important. Okay, so there's a positive positive, there's a positive negative, there's a negative positive, and negative negative. Right? And this looks like to be a circle with an ellipse. So and this one's centered at, looks like 0, 0, 5. So my guess is that if I have a circle centered at 0, 0, this one is also at 0, 0. So it looks something like this. All right, looks like a ring going around Saturn. It intersects at 4 different places. Now it's symmetrical. That's why we have a plus and minus. So this would be not like my picture, but it'd be more perfectly symmetrical on both sides. All right, let's go down to 18. Oh, by the way, you will not have these type of radicals on the actual quiz. This is just good practice. If you practice, doing more difficult problems, when you get to the medium level problems that are usually found on tests, you'll be more than prepared. So think about it as that just good training. All right, going back to, let's see here, 18. Couple ways you can do this. Let's see here. We do have a couple y squared, so we could do some subtraction if you wanted to. Or you could do some substitution, since we have y squared, right, equals x plus 1. You might be thinking, well, it's not y. Well, we don't need to substitute y because there's a y squared down here. So this is actually, in fact, ready for a direct substitution without any extra effort. So that's what I'm going to do. I'm going to go x plus 1, and then don't forget to square it, and then equal to 7. Now that I'm looking at it one more time, I just realized I'm already have y squared. So let me take this off one more time. There we go. Equal to 7. So remember, this actually equals y squared. That's why I don't have to square it. Okay. So as you can see, pretty simple to solve. It's quadratic. I got a square in there, so I need to get it equal to 0. Do factoring, kind of like on number 16. And I want to get it equal to 0 here, so let's start by bringing that down. And we can subtract 7 on both sides. So we get a negative 6, and this is equal to 0. Now this is more direct factoring right here. I don't have to really do the box because there's no number in front. There's not a 5 in front like there was on number 16. So I can just probably mentally do this and say, well, x times x equals x squared. What times what equals negative 6, but they have to add to positive 1. Positive 1. So we'll have a positive 3 and minus 2. Multiply the negative 6 and subtract positive 1. So we have two answers here. X plus 3 equals 0, and x minus 2 equals 0. So x is either negative 3, or x is equal to positive 2. Okay, so plug each one of those in individually and see what you get. So let's do the x minus equals negative 3 first. So the first one, let's plug it back in here. We got y squared equals negative 3 plus 1. So we have y squared equals negative 2, which we are not dealing with an imaginary graph right here, right? We're dealing with x and y. There's no i's involved here. So since we cannot take the square root of a negative here, we've got no solution for this particular x value. So the x equals negative 3 will not be part of my answer. All right, we throw that out. Okay. And next we have what? X equals 2. And that looks like a little more promising. So we have y squared equals 2 plus 1. So y squared is equal to 3. Therefore, y is equal to plus or minus square root 3. So it looks like we get two answers. We have 2 comma positive root 3, right? And 2 comma negative root 3. Also symmetric, right? Anytime we're dealing with squares, we got a lot of symmetry going. So it's a good thing to expect that. Okay? And my guess is, again, this is a circle with a radius of root 7. So if I was going to roughly sketch it, I think it looks like this. This is a parabola on its opening to the right. This is y squared, so it opens to the right. Moved over 1. So my guess is that this looks something like this. So this is 2 positive root 3, and this is 2 negative root 3. And the axes would be something like this. Okay? So that would be a little rough sketch. Again, you don't need to sketch it on your quiz. This is just to have a visual to go along with your work. And if your work and your visual line up and make sense together, you probably did a good job. All right, next, last one for the solving. We got here kind of the same thing we did on 17. You can go through and you could definitely multiply this by negative 4, right? And that would give me a negative 12x squared, which would cancel with positive 12x squared above it. But on closer inspection, you can probably look at this and see, well, 12 is divisible by 4, so 64. And with a calculator, you can verify that 768 is divisible by 4 as well. So once again, I am going to go the other way and just divide all these by negative 4, right? Which is the same as multiplying by negative 1/4. Identically the same. Right? Just makes life a little bit easier with having some smaller numbers. Again, if you didn't do this way, that's totally fine. Right? It's just to have another trick up your sleeve. Okay, and 768 divided by 4, negative 4, would be negative 192. And then the bottom equation stays identical, right? Set up to eliminate the x variables, right? These add up to 0. Elimination method means 2 equals 0. So negative 16 and negative 4 y squared give us negative 20 y squared. And these add up to, let's see here, negative 180. Yes. Divide both sides by the negative 20. So we'll get a positive number, which is good because we can't have a negative with a y squared, and get an answer. So we'll have, what is that, 8, 9, yes. Perfect. So no radicals here. We'll have y equals plus or minus root 9, which is the same as plus or minus 3. So this is the nicest of them all with some nice integer answers for a change. So let's check both and see what we get. We'll have probably some symmetry. We'll have x equals positive 3. Plug it into, let's see, probably the smaller one here. So we'll have 3 times 3 squared minus 4y squared equals 12. Right? Now, 3 times 3 times 3 is going to be, oh, wait a minute. Ooh, I plugged in for the wrong variable, didn't I? Something's off. I plugged in for x. This is y. Try it again. Y equals positive 3. Glad I caught that. So we're plugging in here. That's a little bit better. So we have 3x squared minus 4 times 3 squared equals 12. Okay. This is better. So we'll simplify this. We'll have 9 times 4, so it's minus 36. And then we'll add 36 to both sides. So we'll get a 48. That's good news because 3 goes into 48 evenly. 16 times, and what do you know? We get plus or minus 4. Very nice integer answers, right? So looks like we have 4 answers, plus or minus 3, comma, plus or minus 4. Right, this is a hyperbola with an ellipse, I believe. Yeah, so this probably looks something like this. Opens to the right, yep. So it looks something like this. Where these are the negative, positive, no, what would this be? This would be the positive 3, 4, and positive 3, negative 4. This would be the negative 3, positive 4, and the negative 3, negative 4. Right, all 4 answers. All right. Now, lastly, there's a little bit of what I just did on that last problem, but just so you know, like there are many different possibilities of graphing these. Hyperbola and an ellipse, I only use those two. So I can draw something with no intersection. So if there's a no solution, right, what would that look like? Right, so you can have your hyperbola, but then have your ellipse right here in the middle. Too small to touch it. So that would be a no solution. Remember, solutions mean intersections. So when it says intersections, that's the same thing as solutions. So if we had the equations for these two, and we were doing it this way, we'd get a bunch of square root of negatives, like this one, and we wouldn't get any answers at all. That's what that would happen. First intersection, or one intersection, you could have, let's see here, a couple ways of doing this, right? And it could touch just one of them, like so. Right? That would be one solution. Two solutions, getting a little more familiar. These are the ones that didn't have symmetry, so it touches at 2 places, so it could look something like this. Of course, these are just examples. These are not the only ways of writing these, so yours do not have to match. 3 intersections. Let's do a vertical with the hyperbola. There we go. So 3 intersections would look like kind of like a combination here. It would touch one of them. Right here at the bottom, just touch one time, but then up here it would go through it 2 times. That's less common. That definitely happens. So there's your 3 solutions, your 3 intersections. And then lastly, your 4 intersections is very similar to what we just did here. So we have our hyperbola and our big ellipse going through here and intersecting at 4 places. Okay? And just be able to do this with any 2 graphs, right? Whether it's a circle and a parabola, or, you know, just think about what are all the possible intersection types for each. So you know how many possible solutions there are existing for each problem. Okay, so keep on working at these. You might want to practice some of the harder ones. It's worthwhile. You will get better at math. You'll get better at difficult problems. And then when you come across the other problems, like let's say on a quiz, or the test, or the final, they'll seem a lot easier because you've practiced with harder problems. Okay? So, and also a good rule is to don't do them till you get them right. Do them until you can't get them wrong. So you might have to redo them several ways. Maybe try a different method and show yourself that you can do it all these different ways and not get it wrong, no matter what. Okay? Okay, so good luck and happy studying. You'll do great.